This is Earthfiles, the award-winning news site with the latest updates in science, environment, and real X-Files. Podcasting in-depth reports beyond the 6 o'clock news by Emmy Award-winning journalist Linda Moulton Howe.
I had hoped by now to have the final lab analysis on the water and soil at the Carancas, Peru Meteorite impact site. But Dr. Jose Mature, the geologist at Peru's Ingemet Geological Institute in Lima, has been gone since September 29th, won't be back in his office until October 15th, and no one at Ingemet to date has provided a final lab report. When I last talked with Dr. Mature on September 28th, he was still saying that the National Geographic, New York Times, and NASA's SpaceWeather.com reports about a dense deposit of arsenic at the impact site were not true, or at least not confirmed by Ingemet analysis. After the meteorite slammed into the Carancas Plateau and created a 26-foot wide crater on the morning of September 15, many local residents described seeing water in the crater boil with a bad smell and complained afterward that they got sick. So, what is in the crater water and soil? Since Ingemet has not released analysis, we have to turn to Tucson, Arizona, where meteorite hunter Michael Farmer lives. On September 29th, Michael traveled to Carancas to see for himself exactly what was there. Michael says he first went to the police station for directions to the crater, and that every policeman had pieces of the meteorite in their pockets, and sold Michael some samples. Michael also purchased meteorite rocks from farmers in a village near the crater. Then he says the Carancas police got upset because they decided that they wanted more than $100 per rock. Michael figured he better get out of Peru quickly to avoid being put in jail by greedy law enforcement. So he fled to Bolivia and back to Tucson. Michael Farmer estimates there could be as much as 10 tons of, quote, probably the largest chondrite meteorite to have fallen to Earth in modern times, unquote. You can see photographs of the Carancas, Peru meteorite fragments that Michael Farmer brought back to the United States at Earthfiles.com in a new meteorite report that is featured at the top of the Earthfiles headlines page. Michael cannot believe that Peruvian scientists did not get equipment to dig down through the water and remove whatever is there. Meanwhile, all that water, which has still not been pumped out of the crater, could be dissolving the stony meteorite's fragile rock. Michael confirmed for me that all the fragments he brought out of Peru are breccia, which are clusters of stony material, and he is distributing fragments to meteorite scientists for analysis. There is other data from NASA's SpaceWeather.com about the actual impact moment at around 11:34 a.m. local time on September 15, 2007, south of Lake Titicaca near the Bolivian border. I'm quoting now from SpaceWeather.com's October 7th news update. Quote, on September 15th, a fireball was seen streaking across the skies of Peru, and soon thereafter a watery crater was discovered by local residents near the town of Carancas. At first, experts dismissed the connection. The crater didn't look like a meteorite impact. But since then, minds have changed. Astronomy professor Peter Brown of the University of Western Ontario, Canada, says, quote, without reservation, this is definitely a meteorite. We found some infrasound data recorded by a station in La Paz about 70 kilometers or 43 miles away. From the size of the airwave, we can work out the kinetic energy of the impactor to about 0.03 kilotons of TNT, unquote. That infrasound impact was recorded at 1644 Universal Time, which is close to the first initially reported 11:34 a.m. local time. Professor Brown said, quote, something like 20 to 30 kilograms of the meteorite have already been recovered, but odds are that a good multi-ton monster lurks at the bottom of the crater. The bad news? It is below the water table. The rainy season is coming, and unless some action is taken as soon as possible, the rock will quickly oxidize and crumble, unquote. NASA's SpaceWeather.com says, quote, We are digging for seismic data of the actual impact, the first actual seismic recording of a terrestrial meteorite impact, unquote. Hopefully, more scientific analysis of both the crater water and crater ejecta will be released soon, and I'll report it at Earthfiles and Dreamland. Meanwhile, another scientific mystery is expanding: the disappearance of pollinators in North America. First, it was the massive disappearance of at least 25% of all the honeybees in the United States and Canada this past year in what is called colony collapse disorder. Now it is the severe decline of 4 bumblebee species that used to be prevalent on the west and east coasts, but now scientists cannot find them. In fact, one species known as Bombus franklini, or Franklin's bumblebee, might be extinct. And it's all happened since 1994. One of America's bee experts is Robin Thorpe, Ph.D., Professor Emeritus in the Department of Entomology at the University of California, Davis. He received his Ph.D. in zoology in 1964 from the University of California at Berkeley. Over the past 43 years, he has focused on bees, especially bumblebees. I talked with him this week about the disturbing disappearance of 4 bumblebee species that used to be so prevalent.
We have about 45 species of bumblebees in North America, and of these, 4 are showing rather severe decline in recent years. And I have a hypothesis as to why. The circumstantial evidence points to an introduced disease, which may be another species of nosema that's known to affect bumblebees but doesn't affect honeybees. The honeybee nosemas do not affect bumblebees. Those kinds of tests have been tried.
And would this nosema have to have come in through imported bees from someplace else in the world?
That's my hypothesis, and a lot of things fit that hypothesis, because bumblebees were getting into being commercially reared in the late 80s and early 90s. And in 1992, permission was given by USDA APHIS to export queens of Bombus occidentalis, the western bumblebee, and a species of eastern bumblebee that were candidates for rearing. Those queens then were shipped to Europe, and colonies were reared from them in facilities there where they normally rear Bombus terrestris, which is a European bumblebee, fairly closely related to occidentalis. And then those colonies were shipped back to North America and distributed for pollination purposes. Most of the occidentalis colonies went to the west, and the Bombus impatiens colonies were used in the east, which is part of their historic natural ranges. In the late 90s, I began intensive surveys of Bombus franklini and Bombus occidentalis in the western U.S. and noticed that although their populations were fairly high in 1998, they declined very rapidly in the next few years, and I have not seen occidentalis in the areas where I was surveying since 2003, and I had not seen franklini in its smaller range in 2004 and 5. I did find one worker in 2006 and none this year. So these things have declined very, very severely.
Does that mean that they have actually gone extinct?
I hope not, but that bumblebee was very common all the way from Monterey County on up to southern British Columbia, and it is virtually undetectable in those areas now. My hypothesis is that this disease came into the country between 92 and 94, that 3-year period when queens were shipped to Europe and colonies shipped back, and that those escaped into the environment and began causing this decline in these particular bumblebees, 2 in the west and 2 in the east. We need to learn a cautionary tale from this kind of thing, that we need to be very, very assiduous in making sure that our stocks of things that we export and import around the world are free of diseases.
Jerry Hayes at the Department of Agriculture in Florida told me recently that there may not be enough pollinators in 2008 with the declines across the board in North American pollinators.
Yeah, that's one rather dire prediction, and it could be true. We certainly have to be concerned about this, and I think this is one reason a lot of people are beginning to realize that we are very dependent on honeybees for crop pollination.
Jerry Hayes also told me that in 2006, he attended a meeting that was held by the National Academy of Sciences in Washington concerning an overall and growing concern that there is a universal decline in pollinators in North America.
Mm-hmm. Yes, I attended that same meeting, and they have published a book on the status of pollinators in North America, and there are some grim warnings in there about some of the things that we have lost.
I know May Birnbaum at the University of Illinois, who has studied the genetics of the honeybees in trying to help on colony collapse disorder, said that it is astonishing how little we know about the pollinators.
Yeah, she's absolutely correct.
What do you think could be done to help restore normal populations of honeybees, bumblebees, and other North American pollinators?
Well, that's a very complex problem, and there's a lot of reasons why some of these are declining, and they are different for different species. Most of the feral populations, the wild populations of honeybees, have declined to the point where people who used to depend on them for pollination of their backyard crops and trees and fruits and so on have noticed that a general decline in honeybees that way. Our commercial beekeepers are really at stress in trying to keep viable colonies going so they can stay in business. We're losing not only honeybees, but we're losing people who are working with honeybees as well. It's a very difficult business for a lot of people to stay with and make a living at.
And even if bumblebees don't produce honey, they are a very important pollinator in crops such as tomatoes, peppers, and strawberries, and out to the wild berries and other foods that the wild population of animals such as elk and deer and bears depend upon. If there is a general decline in bumblebees, would the dominoes fall to the fact that even food out in the wild for wild animals will be reduced?
Oh, certainly. That's a threat and a concern. It's unlikely that all bumblebees are going to disappear because we have a variety of species, each of which are quite different from one another. We have 45 species in America north of Mexico.
Do you think it's fair to say that even if this is not on the daily 6 o'clock news, that the decline in pollinators in North America is in fact one of the biggest threats that we have in front of us?
Well, I think so, but then I'm a bit biased because I work with these pollinators and I have a deep appreciation for what they do and particularly what they do in the natural environment. And we're continuously disturbing and destroying and altering habitat out there where these native pollinators persist. The biggest pollination crisis is going to be with almond in California. It turns out that the almond industry has been planting, and they're up over 600,000 bearing acres right now, and at 2 colonies an acre, you need 1.2 million colonies to pollinate that during the period of mid-February to mid-March. So the real crisis is predominantly for one crop, and most of or a tremendous amount of the bees in the country, about half of them, are moved to California during that period. The almond industry certainly is concerned, and justifiably so, and they are looking into alternative pollinators, such as the blue orchard bee. It's being produced in large numbers in experimental plots in the southern part of the Great Valley here in California. It'll be a long time before it ever reaches enough numbers to supplant honeybees, and I don't think that will ever come, but it may supplement honeybees in some areas where there is a real need, perhaps a shortage of pollinators. But overall, it is of concern, and it's hard to predict what will be, but it's not a happy-looking picture.
Jerry Hayes in the Florida Department of Agriculture also thinks it was the USDA's 1992 decision to export and import bees that brought the Israeli acute paralysis virus into the United States. Before then, for nearly 90 years, this country had not allowed the foreign import of insects. So the bottom line is our government has likely shot off its own pollination foot. While bees are disappearing in North America, on this world in the Milky Way galaxy, there could be a planet full of healthy bees in another parallel universe, just like the famous Schrodinger's cat in the physics thought experiment about quantum mechanics. in which all states of existence are probable at the same time, so Schrodinger's cat can be both dead and alive at the same time. Just like atoms are never in only one location, but are in all probable locations at the same time. That irrationality of quantum mechanics caused Einstein and other 20th century physicists great frustration. But now comes mathematical theory from Professor David Deutsch at Oxford University in England that explains how Schrodinger's cat really can be alive and dead at the same time in parallel universes. Professor Deutsch has demonstrated mathematically that the structure of the cosmos must be like a bush with branches, and each branch is a parallel universe. That would mean we on Earth are in one of many probable states that universes can take, and Schrodinger's cat can be alive here and dead in the parallel universe next door, all at the same time, just like the atoms are everywhere at the same time in a molecule. This week, I talked about this revolutionary breakthrough in quantum physics with Professor Andreas Albrecht, professor of physics at the University of California, Davis. Since he earned his PhD at the University of Pennsylvania, Professor Albrecht has been trying to understand how quantum mechanics relates to the universe that we live in.
Many physicists to this day remain very uncomfortable about quantum mechanics, and in fact the textbook I use, which still expresses a lot of that discomfort.
Which is, the cat can't be both dead and alive.
So you can say, well, it's all well and good to say the equations confirm that we get to be certain about this, but what on earth are we actually doing keeping track of all these different outcomes? We like to think of ourselves as really hard-nosed physicists who say, look, I talk about what I can really measure, not about metaphysics. I think I know. Put my finger on this is the thing I'm talking about. This is how you go and measure it. Don't bother me with any other crap. And so here I am, trying to have this hard-nosed attitude, but what do I have as my fundamental theory? I have a theory that says most of my effort when I compute the future direction of physical systems, most of my effort goes into keeping track of all the things that could have happened but didn't. and it just doesn't feel right to large number of physicists.
Well, here is a quote from the Press Association back in September 23rd, quote, "The Oxford team, led by Dr. David Deutsch, showed mathematically that the bush-like branching structure created by the universe splitting into parallel versions of itself can explain the probabilistic nature of quantum outcomes," unquote.
Absolutely. That's absolutely right.
And that's where, to me, it seems that what this does is it pushes us into seeing that the structure of the grand cosmos is one of branches which are parallel universes.
Yes, that's right.
And then quantum mechanics falls out of that as a residue in our 3D world, reflecting those parallel universes.
That's right.
And it would explain how, in Schrodinger's dilemma, the cat can be alive in this universe, it can be dead in the parallel universe.
That's right.
And therefore, the cat can be alive and dead in two different realities.
Right.
How could we go about proving the existence of physical parallel universes?
Well, the most direct connection with the parallel universes comes from laboratory experiments. The catch is that, so you talk about these parallel universes, and what quantum theory says is that for practical purposes, they're separate from each other. But it turns out the parallel universes are never perfectly separated. In the case of the cat, the degree of separation is so great, it's really, really secure. It's securely separated.
That the cat is alive here and dead in another universe.
Yeah. So, but you can consider other systems that are not so solid as the cat. You can go into the laboratory and say, well, here's two parallel universes that I've separated apart. But the interconnection, the remaining interconnection between the two, is not so small as it was for the cat. And I can actually dig in very carefully with my really super high-tech equipment and study that connection. Whenever people have done that, they've really seen it just as predicted by quantum mechanics. So it's not just that the parallel universes are out there, but that they're not perfectly separated. And as you sort of consider the different possible branches, and you consider ones that are more accessible than they are in terms of cats, you can actually see the interference among the branches in the laboratories.
And it is likely that in parallel universes, no matter how many number, even to infinity, that the laws of physics could be very different in each parallel universe.
Exactly. Now, what you hope to do in that situation is work out a way that you can find at least some aspects where the probabilities are very sharply defined so you can actually make predictions. We'd like to make predictions. We'd like to find some sort of coherent picture that ties everything together.
If there are parallel universes, then let's say this 13.7 billion diameter universe might be separated by others with something like an electromagnetic membrane, just to use a phrase. And could it be that the existence of these other universes could relate to the mystery of dark energy and dark matter as we perceive it in this particular universe?
Yeah, some people are trying that line of reasoning, especially the dark energy. They're trying to argue that maybe process of sort of looking for the most probable set of laws of physics will guide us to a set of laws that are closely tied to having a certain amount of dark energy.
And down to the very smallest, the fact that atoms are not in one place, but they are in all places at once in these different shells that make up our molecules, a metaphor for everything at the macro level of the cosmos.
Right, that's right. Definitely how we think that whatever we had to struggle to learn and understand, trying to understand atoms, these same features seem to be at work in the cosmos as a whole.
On the large scale. It comes back to the human looking out at the stars and saying, if there are multiple parallel universes, there must be multiples of us in parallel universes, or at least consciousness.
Yeah, I think so. It's a lot of fun to think about.
Thanks for listening to this Earthfiles podcast from the edges of science, environment, and real X-Files. Go to www.earthfiles.com to see more than 1,000 Earthfiles reports with photographs, drawings, and documents. And visit Earthfiles every day, every week, for new reports and new podcasts. That's www.earthfiles.com.